Well, it's first of all, good afternoon, everyone, and I'm glad to be here. I hope the lunch was great, and I hope my session does not put you all to sleep. I hope it brings you out of your sleep. To be honest, I did not think I could make it today. Until yesterday, I did not have a Schengen visa. So I'm from India, and I need a Schengen visa to come to Europe. I got my Schengen visa yesterday early morning, and I booked a flight right next thing, and I sat on a flight. I just packed whatever stuff I had, and I came. And I hope you folks like the talk. I am pretty much excited to be in Florence. It's a beautiful city. I just had an amazing pizza for lunch, and I'm all set for my talk. So, before we start with our talk, let's just get some formalities out of the way. I am Pratim Bhosale, and I am a developer advocate working with SurrealDB. I have also worked as a backend developer, and I would like to keep calling myself a backend developer lifelong. And since last year, I am in a meaningful relationship with Go. Unfortunately, my relationship with Java did not last long. I will be honest, I tried. I tried for 2 years. I tried to resolve all our verbosity issues by bringing Spring Boot into a relationship. I also learned some fancy testing frameworks, but our relationship failed the test of time. It turns out that Java was not just high maintenance, but it was extremely slow. Anyways, I am currently learning Go and trying to build projects on the side. So if I end up saying something that does not fit right, or if there are any code issues, feel free to correct me. Finally, there are a few folks I want to thank before we get started. First and foremost, the GoLab team for inviting me and arranging this beautiful conference. Secondly, my amazing team back at SurrealDB. Their feedback always saves my presentations in the end, so thank you so much to my team back then. And my amazing partner, Sasha, who is a living ChatGPT for me and helps me debug most of my code. Thank you for traveling the world with me for Go. And lastly, Andrea Favilli, who's a part of the staff, who has helped me throughout my visa process and has been very understanding and supportive. So yeah, that's all with the acknowledgements. Let's rewind a little bit. The first thing that I did after I landed in Florence was I searched for pasta near me. And because obviously I'm in Florence and I have to try some good pasta. And to be honest, our talk today revolves almost around this one screenshot. We are going to break down the screenshot and see what is happening in the screenshot, why is it happening, and why did I end up having the pasta where I did. And it was amazing. I had pesto pasta and it blew my mind. But can someone from the audience tell me what all do they see in the screenshot, like a quick couple of things? Okay. So, oh yes, there's a obviously there's a map, and there are some more specific things that will lead us to what we are going to discuss today. Yes, that's great. So just to bring it out, we can see that I have a list of suggestions given, recommendations that are come. So now these recommendations, why are they in the way that they are? We will talk about that. Then there are different parameters on the top which Google Map gives us. Like the first one is within 400 meters. The second one is open now. Then there's top rated and everything else. There's also the use precise location, which I hadn't switched on, but that if I would have used that functionality, I would have had more a different or a more redefined solution. We will be talking about how all of this comes back to code and what does it mean when we are going back. So what are we going to unpack today? We will be going backstage into the engine room of location-based recommendation systems. We're going to talk about location-based recommendation systems and what its textbook definition is. We'll see why I chose to build it with Go. We'll also see some existing geospatial libraries in Go. We are going to break down some heavy jargons that you might hear while I'm talking. And we are going to see how this all fits on the database layer as well as the application layer. Basically, what you search on your applications, what happens on the backend, what happens on the database layer. We'll try to just have a basic understanding of it. We won't go in depth because that would obviously put everyone back to sleep, and that is not what I want to do. And yeah, we'll wrap up the talk with a quick demo where I will show the location recommendation-based system that I have built and what output I get from it. So we are into the world of recommendations, and have you ever wondered how does your favorite food delivery app always know what you're craving for? Like, if it always happens with me that if I want ice cream, unfortunately or fortunately, the search bar of the very famous food delivery app back in India, which is known as Zomato, it literally in the search bar says ice cream right in the search bar. It's that smart. Like, it doesn't even wait for me to type. It already has it. How does that happen? Like, it does look like magic, but is it literally magic? Because we are all developers, and at least we should be the ones who don't believe in magic. So that's one thing. Or the next thing you can think of is, how does a travel app recommend those hidden hostels that fit exactly into your budget when you're traveling? And it won't recommend you those fancy hotels which are way out of your budget. So there is the magic of location-based recommendation systems working on the backend. There are some more examples which I have listed out there, and some of them are the navigation and travel apps. I want to understand from you what are some famous navigation apps that are used majorly in Italy and Florence. For example, back in India, everyone has Google Maps and Apple Maps. Does anybody use Apple Maps here? Oops, I am with you. So I normally get kicked out of my group because I'm the only one who uses Apple Maps. But I don't know, I like Apple Maps and I've been used to it. But yeah, coming back to the topic, even though there is Google Maps, there is Apple Maps, there are still a lot of applications that are doing navigation systems very specific to a region, and people from that region can prefer them over Google Maps and them. To give you an example, in London, there is a navigation application named as City Mapper, and that is very famous, and people prefer City Mapper over Google Maps. Are there any such navigation apps that people prefer in Italy, if anyone from the audience knows? Cool, I think we are all team Google Maps except me and Mr. Nice Black Coat behind. Yes, so that is with the navigation travel apps. We have Airbnb, which uses a lot of location-based recommendation systems. We have Amazon in the retail section. We have LinkedIn in the job search section. We have Uber Eats in the food delivery section. We have literally every social media application in the social media area. We have event planning like Meetup applications. Sorry. And we have news platforms. We have transport applications, and one of the most famous applications that I'm pretty sure everybody of us is addicted to and is getting all our updates about what's happening with OpenAI is X. X uses location-based recommendation systems heavily. Like, everything you see on X is because of the location you are in, but it also gives you the chance and the possibility to cater according to your choices. By the way, how many of y'all are up to date with what's happening with the whole OpenAI drama? Oh, that's good to know. Cool. Let's get back to our search image. I'm just going to go back and show the search image. So coming back to the search image, to tell you exactly what are the parameters I was talking about is when you're using location-based recommendation systems, the search, the filtration happens based on different kinds of mathematical functions, which we will be seeing forward. But some of them help you sort your recommendations based on distance, which is like within 400 meters. Some of them helps you sort it based on some kind of threshold, for example, ratings. Like I will always search for restaurants above 4-star. That's something. If you see the recommendations that I have got are not in the way of distance, because, okay, I don't see the distance here right now, but the first one is 4.4 star rating. The second one is 4.3 star rating. And this list is sorted based on the ratings. So you could have your list sorted based on, for example, the closest distance or the ones that are open right now. And that's what this whole picture is about. We will go ahead and see how this falls into Go functions. And finally, the use precise location, I will try to map it to something from our technical terms. But what happens, what is working when somebody is not using the precise location, and what happens when somebody is using the precise location is something we'll see ahead. Cool. So this is the last time I'm going to say the whole location-based recommendation systems. It's a pretty long phrase. But what is it exactly? To put it in very basic terms, it's your digital guide that takes your location and suggests things that you might like. It's literally available to you on your phones. And it's not just based on what is near, how closest is the distance. It's also based on your preferences. It's also personal. The system, location-based recommendation systems, they learn from your preferences, your habits, and align that with geographical data to serve the choices that are exactly tailor-made for you. And the first term in understanding location-based recommendation systems is geocoding. The definition is right up on the screens. It's pretty simple. Geocoding is nothing but taking a human-readable address that we all type, or we all just say, hey, I stay at XYZ place, into geographical coordinates. And what I mean by geographical coordinates is latitudes and longitudes. It's that plain simple thing. Imagine like if I was in New York and if there was a restaurant named Carpe Diem, I'm not sure if the pronunciation is right, but I wanted to order a pizza from Carpe Diem in New York, and I searched for that restaurant and I ordered it. And if geocoding was not there, there would be a high possibility that it could match search Carpe Diem, the pizza restaurant from Florence, and try to send me a pizza from there. So that pretty much makes it clear the requirement for geocoding, which is required for us to convert human-readable address into coordinates so that the machine code can access information based on location. Because machine does not understand human-readable address. It can. We will be talking about the reversible format, but the basic understanding is to convert it into coordinates. Now, one of the most widely used geocoding APIs is Google's geocoding API. There are other APIs available too, but I haven't done quite a lot of research in that. I went with the most easiest and the most helpful API documentation, and that was Google's documentation. Let's take a look at it. So this screenshot basically will tell you everything you need to know about how you can set up Google's geocoding API. You basically first have a Google Cloud account. You then create a geocoding request. The request will take in your API key. You try to, if you want to convert the coordinates back to an address, you could also do the reverse geocoding, which is also available with the API. You can also understand the basic formatting of the response, which we will go ahead and see. We'll create our own JSON, which will help us understand what kind of data we are passing to the code. And finally, once you have the API set up, once you have the API key access, you can literally use it in any of your application. I would definitely recommend and suggest you folks try it out. It's pretty straightforward, and there are a lot of tutorials and documentation support to help you get started with it. And yeah, let's get to the point where we will just see the Go SDK of geocoding. So in front of you, we have a very snappy Go snippet that leverages the Google Maps to turn a basically like a regular street address into a precise address of latitude and longitude coordinates. It's a very small, straightforward snippet. And this is the first step that is required to build any application that is location aware. Let me show you how straightforward it is to like, this is how you can convert any address into the coordinates. Well, it's very important that you do not use the insert API key here and add the actual API key, and also not share with it. Share with anyone. This is a personal API key, which you should make sure it's in your environment in env file and not on your GitHub code. If you see there, we have a geocoding request struct. Now, the format of the struct is based on what are our requirements from, what do we want from the struct. We have a preferred language that we've put as Italian. We also have the region that goes into it. And you can adjust these parameters based on your application's requirement. Once your request is set, we will call the geocode method, and we will pass in our request. And under the hood, the client handles the conversation with the Google servers. And like any good conversation, we get a response, of course, provided we ask politely and with the correct API, and if the service is available. The response contains the precise latitude and longitude coordinates that form the bedrock of any location-based service that we are using. So yeah, in just a few lines, we can take a human-friendly address and convert it into latitude and longitudes. That was easy. And coming back to the big question, why are we doing this in Go? Why are we building this in Go and not any other language? Now, the answer is extremely tough. It took me years and years to understand why we're doing it in Go. And I think I finally know it. And it's because I don't know JavaScript. I'm sorry, I'm not the best comedian. I'm trying my best. At least I have done my best with the images. I hope you liked my gopher. But yeah, on a serious note, we all know this whole conference has been about why Go, what are the best things about Go. So I'm not going to reiterate on it. But as we all know that Go strikes a remarkable balance. It makes sure that we get performance within very easy syntax. And it's either, even if it's for microservices or full-blown distributed systems, the simplicity in terms of understanding any function and getting started is pretty much easier with Go. That is why I chose Go. Again, the other reason is because Go is one of the only backend languages that I prefer coding in. And yeah, Go is modern, it's real-time, and it's basically making sure that different tech fads come and go. But we all, as Gophers, we have a particular fondness towards Go, and due to these very important properties of efficiency, ease of use, I prefer building this in Go. But if with the Google's geocoding API, there is access for other languages also. There is support for other languages, so feel free to check that out too. And next, we will be talking about geospatial libraries in Go. Now, another reason why I preferred Go was because of the support Go had for geospatial libraries. Now, you could use any of the libraries from the open source libraries already available, or you could use the default libraries that the Go Foundation recommends. It's completely up to you. I haven't added the links because I didn't want to have any opinion on it, but feel free to go ahead with any Go library in Go. But the best part is most of the libraries are very powerful and they are always up to date. We are going to see a couple of them and understand how they work, so that you at least have something to go back with. The first one is the S2 geometry library. It is again developed by Google, and this library brings the approach of mapping by dividing the globe into a hierarchy of cells. It was pretty heavy for me to understand in the first term also. And this part of the presentation I have studied specifically for this talk. I am not an expert in these libraries. I have gone ahead and taken the route of using the geocoding API of Google, but just to make sure that there's more information about what's out there, this is what I have added, which is S2. And the second one, the best thing about Go's emphasis on performance and concurrency is that S2 makes sure that it's integrating it very well, and it can handle complex spatial tasks with quite a lot of precision and speed. In short, I can definitely say that S2 is great for creating accurate and scalable geospatial functionalities. The next one up there is Style38. It's again a library that distinguishes itself in the geospatial toolkit. Integrating Style38 with Go is pretty much straightforward and shouldn't take a lot of background knowledge. And it not only provides storage and querying for geospatial data, but it also gives you the capabilities of geofencing. Now, I have dropped in another jargon, but I will go ahead and explain what geofencing is. And we're going to see a quick snippet of how the S2 geometry library works in theory. Here you can see that S2, we are using a Go function that uses S2 to find all the points within a certain radius. This type of spatial query is important for any location-based service. And this snippet is just so that you get a taste of how Go, when you pair it with S2, handles the geospatial logic with minimum drama, but maximum efficiency. Cool. Yeah, I've just added the S2 one. And so by now, we have heard the term geocoding. I also dropped the term geofencing. And there's going to be another term that I'll be dropping, which was also a part of the talk title, which is geofunctions. Can anyone, if you folks have studied around these domains, tell me the difference between these three terms? If anyone has an idea about it. Cool, that makes things very easy. I was so scared that there might be that one expert sitting in the audience who's going to grill me. But this makes things a bit easier for me. So I think we've already discussed what geocoding is, right? It's nothing but converting a physical address into coordinates. And next up, we are going to see what geofencing is and geofunctions are. And these terms are the heart of location-based recommendation algorithms, and they're extremely integral to it. So next time somebody uses these terms, you know what they stand for, and you won't be jargonified. I don't know if that's a real word. Again, please give a shout out to my special designer who's created these amazing images for me, and that's OpenAI again. So imagine drawing like a virtual magical circle on a map. you have a map and you're drawing a virtual circle over it, not a physical boundary. You're not going and putting a physical boundary, but you virtually know that this is the area that I want to focus on. That is geofencing, basically. To put it down to how it would work on an application basis is, imagine like you have an application that tracks truck drivers or tracks how your consignments are going from one area to the other area. And the moment it crosses one geographical boundary, there is a flag raised, or there is like an alarm that goes off. There was never a physical line available, but it was a virtual area that was defined, and that is what geofencing does. It basically helps you, like, the most common application for that is having security system built over geographical boundaries. Next up, we are going to see geofunctions. Now, geofunctions are available as separate libraries, as individual libraries. Geofunctions are also available with a lot of databases. And the way I have done this is with SurrealDB. SurrealDB is a multimodal database. And each of these functions is basically a complex method of having mathematical functions that can manipulate your geocoordinates. So we are going to talk about geo area quickly, and it basically calculates the area of any geometrical function or any geometrical polygon or freeform shape, and it helps you come up with the area. Next is geobearing. This is a very interesting one. Geobearing is majorly used in nautical science and the nautical domain area, where it helps you find things which are right in straight of you or in perpendicular ways. It does not give you the exact location, but it is majorly around understanding navigating areas. Drones are also an example that use a lot of geobearing. Next up, we have geocentroid again, which is basically finding the center of gravity of a shape. Examples of it are urban planners, geographers, campaign strategists. When they want to pinpoint the heart or the heart of a city and to understand what is the hub of any area, they majorly use the geocentroid way. Next up, we have geodistance, which is the most commonly used function. Geodistance is nothing but using the shortest path between 2 points. And the function that the screenshot that we saw used geodistance to tell me which was the closest. Now, it definitely did not use this particular geodistance function, but it used some geodistance function on the backend to give me the closest way. This is the most commonly used geofunction out there. And lastly, we have the hashing and the encode-decode functions, which help you convert a geohash into human-friendly coordinates. And yeah, with that, we had some clarity about what is geofunctions, geocoding, and geospatial data. Next up is the database and the application layer. And now that we have explored most of the things about geofunctions and how they refine our interactions with geospatial data, we can now pivot to a different but equally crucial point, which is understanding how do these calculations happen and whether these calculations should happen on the database layer or the application layer. Now, if they happened on the database layer, there would be efficiency and convenience that would come into picture. How it's a bigger topic to discuss. With the time that I have, I won't be able to go into deep, but we can definitely have a conversation after the talk. There's another way. What you can do is you can delegate these tasks on the application layer, and that would give you more flexibility to play around with the functions. But this decision is basically what shapes how your system will respond to the real-time location needs of your real-time location needs for your application. Lastly, we're going to check what happens when we perform our map-based calculations. The database layer is what comes out to be on the top for its speed and straightforward approach. It's not just about like dropping pins on a map. It's about doing it quickly and precisely, which is something that is very closely connected to indexing. Now, when you have the functionality of indexing available with a database, you can search for these different filters faster. Now, a lot of databases have indexing inbuilt in it. You can pick up any database that you like. I went ahead and did it with SurrealDB because it has its own query language, so I did not have to do a completely different search functionality and then add it to the database. Besides just mapping, databases can do a lot more. You can search through the text, you can sort through data, you can connect different pieces of information. Basically, which the whole point of this is doing it. I prefer doing it on the database layer because it helped me give more access to doing different calculations on the database layer. But it's completely up to you what you decide. Each layer has its strength, and the best solution can sometimes be the mix of both these domains. And we are now to the last part of the session and the talk, which is the demo part. Before we go ahead with the demo, I would like to go through a quick walkthrough of the code. We will start by saving the user's locations in our database. So to give a quick background understanding, I will also share the link of the code, but I am using SurrealDB here as my database. And this is the save user method. What I'm doing is I'm updating users' geolocation data, and our application basically is interacting with the real world data, determining how and whether our users will get personalized recommendations on their location. It's a pretty straightforward method. And the similar method we are going to use to save the restaurant's details in the database. So this is the JSON that I have with all the best places where I can have a gelato and their addresses. And yeah, this is, again, a save restaurant method that is pulling my data from the predefined JSON that I've given. Geocodes, what it's going to do is it's going to geocode each restaurant and then populate some eateries into my database. And finally, what I'm doing is adding the recommendation part, where we are going to fetch a list of restaurants closest to my location, which is powered by the geolocation, the geo functions. And the location that I had put here is the location of this hotel. And let me just spin up the code quickly. Just a minute. Yes, got it. Yes, just a minute. So most of the major parts I have already explained. Oh my God, what I said is something that I did not follow. My API key. Thank God my API key is not visible. But yeah, just gonna quickly run it. I'm just gonna. So yeah, this was the major file, which consists of our code snippets. We sign into the database first. I'm sorry, my laptop's taking time to respond. Yeah, it's pretty slow. Just a minute. Yeah, I think it's lagging. But you can pretty much see the response here. I have first given the user location details. I've saved the user, and I'm then searching for the gelato places closest to me, and it says that the one that is closest to me is, it's Gelateria Santa Trinita. That's one of them. These are all the gelaterias that are available, and when we search for the closest one, it is this one. Oops. Yeah. So yeah, that is mostly all about today's talk. Let me just go back to the, oh, thank God. And this is all about today's talk. I hope I did not put you folks to sleep. If I did, I'm extremely sorry, and the next espresso shot is on me. Please share your feedback with me. I would love to know if you liked the talk, if you thought it was helpful, what I could do better. It will take a second for you to share your feedback, but it will be very helpful for me to have more sessions that are helpful and fun for everyone. Thank you so much, and over to you.
Thank you. Thank you. Thank you. Okay, so we have about 10 minutes. If somebody wants to ask something to Pratim, and you have a question?
Okay, thank you for your presentation. I just have like 2 quick questions. The first one is regarding to the geocoding service. Does the service or the library support reverse geocoding? And the second one is regarding the functions, the geofunctions. The units of those functions or the outputs are like degrees, or you can query the outputs as kilometers or meters?
For the first question, yes, the service does support reverse geocoding. It is Google's API. So Google Maps has a lot of functionalities available. Geocoding is one of their services. There are a lot of other, like there's directions, there's geo-directions, there is a plethora of functionalities available. And yes, it does support reverse geocoding. And in terms of the geo functions, it depends upon how you want to convert the data. If you want it in kilometers, you can get the data in kilometers. What kind of measurement system you are using, you can always code that measurement system using a logic. But for example, when you're doing geo distance, it is calculating the distance between 2 points. So it would be, I'm not very sure, but it would be in terms of distance, and it will give you an option of if you want to go from meters to kilometers. But the most common would be, if I'm not wrong, meters or centimeters, but I can still check and let you know the exact details, yeah.
Anyone else? Okay. Okay, thank you, Pratim.
Thank you so much.
Okay, I guess we can skip to the other talker. Thank you very much.
Thank you so much.
Very interesting.